All right. So yesterday we did a lot of text pre-processing, and some of the things we looked at. First of all, we looked at the applications of natural language processing in the business world or in the real world. And one of the things we talked about as the applications of NLP, one, we looked at sentiment analysis, deriving sentiment from customers' review of a particular product or brand popularity of fashion trend. We looked at that on the applications of NLP in terms of trying to determine uh, this customer satisfaction for a particular product, that NLP can be used to perform sentiment analysis in that area. We also looked at Google Translate, like machine translation, which deals with the process of translating text from one language to another target language, like translating text from Chinese to English or English to Chinese. And this could be very well applicable, especially in the airline industry, for customers who maybe who speak one language, let's say Chinese or German, and they want to board a ticket or a flight going to an English country. So they might as well, just translate from the original language to the target language, or from the target language from English to Chinese, for them to be able to understand the options they have while trying to book the flight. So this is already, is already going, like we already have the applications going on. That's part of AI, which core method behind it is the natural language processing. We also looked at text to speech yesterday, and we experimented that. We saw how Python could translate our words to audio file. We did that yesterday, and we all saw that using the play sound library. And then the other processes, the basics of NLP we looked at what we call tokenization, which is the process of segmenting text to individual words or tokens, including the punctuations. And we used a popular library yesterday, that's the NLTK, which stands for the Natural Language Toolkit. Then I remember I said that NLTK is not the only Python library that is used to process text. We have SPACY, SPACY. We also have the GenSim library. But for this training, I'm only using the NLTK, which kind of like the foundation, or I won't say the simplest, but it's very popular. But GenSim and SPACY are also being widely used now, but even in the industry. So, but for this training, we only stick to NLTK, because once you understand NLTK, it just is simple, just small difference to learn GenSim and SPACY on how to process the text. GenSim can do everything NLTK is doing. Likewise, NLTK. So we also look at what we call the stemming and lemmatization. And stemming is the process of reducing a given text or a word to its base form. We looked at, for instance, if you have in a text, you have some words like go, going, goes, gone. Those can actually populate your text and hinder us from actually focusing on the important words in the text. So we introduce the idea of stemming on how to reduce those words to their base form, and we did that yesterday using the NLTK. But we also saw some cases where the stemming may be too harsh or may fail. Like when I mean fail, it means that it's not giving us the desired output that we want. So because as a data scientist, when you apply this method, you have what you need at the back of your mind, what the result you are hoping for. So when we checked it yesterday, we saw that for some of the text, it wasn't giving us the desired output. So we introduced what we call lemmatization. And lemmatization is similar to stemming. However, it's different, because lemmatization its goal is also to reduce a particular word or text to its base form However, it's reducing that to its base form, matching it with inward dictionary. So it takes a particular token or word and looks it up in the dictionary and give us the dictionary matched base form. So in other words, when a lemmatizer does, if it cannot find the dictionary base form of that word you are trying to look up, it will just give you back the word. So, we also did some examples. We saw some result of lemmatization. We saw that in some cases, lemmatization result was better. However, it's also not perfect. But, sometimes depending on what you want in mind, depending on the result you are looking out for, lemmatization can be preferable to stemming in most cases, but not in all cases too. So, and we also looked at the removal of stop words. We talked about stop words, and we said that stop words are frequently occurring words that do not really convey much meaning. Words like articles, like a, and, the, that, pronouns, prepositions, words like I, myself, himself, all of those words that may occur frequently in a particular text, but do not really have much meaning to what we are trying to derive inside, to the insight we are trying to derive from the text. So we concluded that in most cases, it is better to remove the stop words from the text you are trying to pre-process. And the last thing we did was to visualize our text using the frequency distribution, where frequency distribution is trying to give us the number of occurrence, or how many times a particular word in a text occurs. So we use the NLTK freq disk to visualize the clean text that we did. So today I'm just going to introduce you to another, we're going to kick off with another way to visualize the text that you have, which is far more or far better than frequency distribution, in the sense that in the marketing firm, suppose you have a customer review, or you have some reviews about a product, and there are so many that you don't want to, it will take a lot of your time to read all of these reviews. So the first thing we can do is to throw this text raw as it is into a word cloud, and it will give us a visualization of some words that pops out. So from there, as a marketer or a data scientist, you can give that to a marketer, and you could quickly see some of the words that the customers are using. So you will know if there are negative words or positive, even before you do anything on the text, before you even process it. It can help us to quickly see some top words that come out in the text. So that's where we're going to pick up this morning. And then we look at part of speech tagging. That's what we're going to look at. Name entity recognition. And finally, how to turn the text to numbers, so that if you want to do a machine learning process on it, then we can proceed from there. That's what we're going to do today. So the first thing I would do, if you want to run this along with me, you can uncomment this from the notebook I gave you. I know I couldn't give Miss Timothy, but yeah. So, but if you're running this with me, just uncomment this to this line, this first cell, and run it. What we want to do, the first cell is trying to install the word cloud library. Yeah, so it doesn't come with your Anaconda, so you have to install it. So just uncomment it and install it. And then I have already installed it, so I don't need to do that again. So this pip install word cloud, it should, I think it made a mistake, it should be WRD. Yeah, so I'll copy this and put it in the chat in case you want to do that, and so that you can run that. Okay, so I've put that in the chat. You can run that, and that will install the word cloud. So I'm going to kick off from there. So this is a sample text that we want to visualize. Text preprocessing is the process of turning blah, 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 and all of that. So first thing, run that cell. When you run it, since you are dealing with visualization, the popular library which I've introduced to us in the first training is matplotlib. So import it, import matplotlib.pyplot as PLT. Now, suppose you are able to install this word cloud in the first cell. So this second cell now, from the word cloud that I've already installed, import this word cloud function, this method, starting with capital W and C, capital C, like that. So import it. Then the next line, what I'm doing here is to instantiate this word cloud that I import from this library word cloud. So I instantiate it here. Random state is just a seed, meaning it's optional, but it's a seed to make sure that I get the same, because this word cloud is generating the text randomly. So if I want to get the same output every time I run it, I have to set a seed. And in Python, you do that with your random state, random underscore state. You can give it any number. I just use 0. So that's what this is doing. Dot generate. That's what we generate the word cloud from what? From this text. So this is saved as a variable text. So generate, passing your text there. So when you generate that, I save that into a variable W cloud. So, and then to show it, to show the word cloud that I've generated from this first step, that's what I'm trying to do. A PLT dot im show means image show, because this is actually an image, even though what is in that image are text. So anytime you want to show an image, you use the im show. That's what you're doing. So im stand for image. So what do we want to show? This word cloud that we have generated in this step. So that's what I put here. This argument, interpolation equals to bilinear, is optional. Let me remove it and then you see. We can cut that out. So if I run this, let me uncomment the plt.show. Let me even comment that so that you see what's going on. So if I run that, you see, this is what I have. So we still have the axis there. And so that's why I put this here to remove the axis. Now, this, when you see matplotlib.email of that, that's why we normally put plt.show here, so that it will remove some of unnecessary stuff like this. So if I rerun that, you have this. Now you can see the axis is gone because I removed the axis, and that matplotlib something is gone. So the argument interpolation is just to perform some interpolation on the image, just to beautify it. It's optional. So if I run it, you may not see so much difference on it. So it's just to make it finer and beautify it, but it's optional. So this is what we call word cloud. I can label it. If you want to label plt dot maybe title. We already learn how to do matplotlib. So title, we can give it word cloud of a sample text. So we can run this, and then we just label it. So this is what we called a word cloud. So you can see if this text is actually large enough, it may take you some time, going through the hotel, but throwing it into word cloud, we can see some word that pops out: text, process, pre-processing, indexing. These are some words that jumps out. So suppose you're in marketing, you're working as a data scientist or a data analyst in a marketing firm where they have a lot of reviews, text on a lot of review from customers on a particular product or brand. If you have that, one of the key things that you can quickly do is to just throw those reviews before trying to understand what customer were trying to say. Just throw them to word cloud, and it will give you some words that pops out. Maybe they say, oh, bad, this, good, excellent. You will quickly see some of those words, and that might give you some kind of an idea of some of the things you will see when you start working with the text. So it's a good skill to have, and something like that when you are working with text. So it's part of text analytics. Okay. So moving on from any question before I move to part of speech tagging, before I move to the next thing. Any question?
No, sir.
Okay, are we good with everyone? Can I move on?
Yes, sir, you can.
All right. So the next thing we want to look at is what we call the part of speech tagging. So why is this, what is part of speech tagging and why is it necessary? Part of speech tagging, I briefly talked about it yesterday, that is actually the process of categorizing each word or each token. A word is also known as token. So it's the process of categorizing each word in your text into its respective part of speech. Like we know the part of speech, noun, pronoun, adjective, adverb, verb, preposition, and things like that. Determiner, that's all this article D and all of those things. So we use these, is actually necessary if you want to do some advanced natural language techniques like topic modeling. Maybe you have news articles and you want to know the type of discussions going on in those news, the topics discussed there in a particular text that you are given. It could even be still reviews or so many, like some text, a particular text you are given, be it news or a particular review on a product. You want to know what they are talking about. You can do part of speech tagging to categorize them, to annotate them, to label those texts into is part of speech, to know what and what you are trying to attach categories to each word in the text. That's what part of speech tagging is actually about. And you can still use NLTK, Natural Language Toolkit, for that. So suppose we have this sample text. I am a student from the University of Alabama and all of those. Suppose this is the text that you have. Let me put full stop there. So let's run the text. So if you want to do part of speech tagging, you have to start. Remember I said yesterday that the first step you do in pre-processing text or in analyzing any text, the first thing you do is tokenization, meaning break it down, break those texts to individual words or individual list of sentences. That's the first step. So here I just import some of the things I will need. NLTK, that's the library we are working with to analyze the text. String, I import string here because I know the text may include punctuation. So we import string to remove punctuations. From NLTK, import word tokenize. This word tokenize is what we're going to use to tokenize or to break down the text. We used that yesterday. POS tag. I may remove this. Yeah, I don't even need that for now. But that's the function that we're going to use to generate the part of speech tags for each word. So from NLTK corpus, import stop words. We may still leave all of these for now. We may not, you may not remove the stop words for now. Let's not do any pre-processing. Let's just see the raw text first. So the first thing you do, tokenize the text. Take this, your function word tokenize, and pass your raw text into it. Pass it there, and then save the result. The result will be tokens. That's list of strings. List of strings. That's what that token is, each word, including the punctuation. So let's save that to tokens, and then let's just view, let's see the result of that and say our tokens. Okay, you can see it tokenizes. So these are what we call tokens. It breaks them down to individual words using the white space. When I mean white space, I mean the space in front of each word. I am a student from, like that. It includes punctuation. You can see the dot, the comma, each of all of the words there. So looking at all of these, that's why it might be necessary to now remove stop words, because you can see some, look at I am a, D, I, like that. They occur many times. look at some punctuations, A and all of that. So this may not really help us get the importance or to focus on some important words there. So that's why pre-processing might come in. But I still want to, let's still leave it like that and do part of speech tagging. So if you want to do that, I have to call on the NLTK and call on, so from the NLTK, use the POS tag. If it's there, if I don't want to see, after NLTK dot, press tab, you see it there, it's loading. So if you see the POS tag, so it's actually in NLTK, and then passing this your tokens. And let's look at the tags. So we save it in a variable called tag. So let's see what we have there. You can see. So it attach part of speech to each word. I. PRP means proper pronoun. PRP, that's what pronoun. That's a verb. A, that's DT stand for determiner. You know, so A is a determiner. Student, you recognize that that's a noun. Now, from, I think this is, I think that's interposition or something like that. D, that's still determiner. University, that's a noun phrase. You know, it's telling us that it's actually standing for a location, things like that. Alabama, so these are places. So you recognize that Canada, noun phrase, Ontario, you know, things like that. United States, United, so this is it. So all of these are what we call the part of speech. So what it's doing is attaching part of speech to each of your token or each of the word that occurs in your text. So the first thing, tokenize it, that segment those texts or individual words. The next thing is now we want to look at part of speech tagging, which is what we've done. So, but now suppose that we want to do the pre-process. I believe we focused on that mainly yesterday. But for the sake of those joining us today, we can do that here. That's what I did here. Okay, so this suggests we should do some pre-processing. So what this line is doing is a forward in these tokens that we have done, forward in tokens. Print that word if the word is not in stop words. So I have to uncomment this, then we need the stop words. We need the stop words. So here, let me go back to the stop words. When you import the stop words, instantiate it, but these stop words are in many languages in NLTK, but here we need only the English language. So that's why call on the words on this stop word and specify English, since we only need English. So back to this line now. For word in tokens, print the word if the word is not part of this stop words list, and also if the word is not a punctuation. That's why I mean by not in string punctuation. And also not digit. Word is digit, meaning it's not a number. I don't want digit. I want to remove digit. I want to remove punctuations. I want to remove stop words. That's what this single line is doing. And this method is what we call the least comprehension. Yeah. So we also looked at that yesterday. So, and then, so this single line will do the pre-processing for us. And then the next thing I did here is just to repeat this method here. Like do the POS tag, NLTK POS tag to attach tags like the part of speech tagging. Then let's see it again. So you will see now that it has reduced. We no longer have all those comma, full stop. We no longer have most stop words. However, maybe I should lowercase it first. Maybe I should remove, like put lowercase, like turn the words to small letters, you know, something like that. Maybe, but it doesn't really matter. If you want to do that, you can as well just put dot lower here, and it will do that for you, but maybe it's not necessary for now. So you can see our text has been reduced. So we can focus on maybe these are the important words used in the text. So what we've done here, we've tokenized the text, we've cleaned it by removing stop words, punctuations, digits, all this number 4 dot and all of that, all this A, they've been removed. And then we also obtain the part of speech tagging for that. Any question before I move to the next thing called named entity recognition? Any question on part of speech tagging, tokenization, and all of that? Any question?
No, sir.
Mr. Timothy, are we good?
Yeah, I'm trying to follow up. I'm following.
Okay. Moses, Mr. Moses, are we good? Okay. So let me move on there. So the next thing we're looking at is what we call the named entity recognition. And the named entity recognition is kind of just a step forward after part of speech tagging. The two work hand in hand. So they're kind of just a step forward. And what does it mean? It's also an annotation approach, meaning we're trying to label your text based on if that text, you are trying to annotate them, to label them into different categories like places, organization, people. Like you are given a particular text, you want to analyze it, you want to know what and what are in those texts. That's all we are doing. What and what are in the text? You know, like do they mention some places there, some people, some organizations? That's what you want to look at. You don't want to read the whole text to figure that out. So you want to quickly bring them out. You visualize it. You've seen some words, but maybe those words, you don't really know if they stand for a particular organization or a particular place or a particular person. You don't know. You've used word cloud. Okay? So you want to do that. So that's what named entity recognition is. All these skills, they're very paramount because one of the most difficult data to work with in the real world is text data. Text, images, those are actually most difficult type of data to work with. And that's why many people run away from this area. So you building up a skill in natural language processing will give you an edge later on, in this field. So because they are not structured, they are classified as unstructured text, unstructured data, not in rows and columns. But you can as well take it to a point where you turn it to rows and columns, which is where we're going to stop today. So, all right. So that's why I put it here that named entity recognition is a type of text annotation tags. And in that named entity recognition, words are labeled or annotated into categories such as organization, location, people, places, and so on like that. So we're still using natural language toolkit, NLTK. So the first thing, import your NLTK. From NLTK, there is a function called NE-chunk, meaning NE stands for named entity. Chunk, meaning you want to chop them, you want to divide them into, you want to categorize them into this the different category like organization, people, and all of that. This second word tokenization is just to tokenize it. If you have imported once, you don't need to import it again. So I'm just showing every cell as if you are starting from the beginning. So suppose you have a particular text called the President of Nigeria stays at the Aso Rock. That's the first text that you have. That's the simple text you have. The first thing, remember, is tokenization, meaning splitting your text into individual words, including the punctuations. You are splitting them by the white space. When I mean white space, I mean the space in front of the word, each word. That's what this line, what tokenize, is doing. Okay? Then after you've done that, the next thing you want to do is to tag it, to categorize that token to individual part of speech. I must say that before you can obtain the named entity recognition, you must perform part of speech tagging. That's why I said at the beginning that name and recognition is a step after part of speech tagging. Yeah, and I will show you. You will see it now. So this third line, this line NLTK.pos tag is performing what we've done here, the part of speech tagging. And then the last step is actually the one that produces the name entity recognition, this NE_chunk. You can see what we pass into it. It is the tag that we obtained in the previous step. If you want to know, check the input whether it's correct. Just put your cursor down and press Shift Tab. You can see NE_chunk. What do you have there? Tagged tokens. That's the input that name entity recognition function must accept. It's not going to accept ordinary token. It must accept the token that you have already tagged into his own part of speech. That's why I say you must perform part of speech tagging before you do named entity recognition. Okay, so that's that. So if you have done that, I just print it here and then look at what I have. So you can say it's doing both. For the article D, it gives you the tag, the part of speech tag as a determinant, but no named entity for that. For president, it gives you that, but the only one is giving you named entity recognition for. Look at Nigeria. You see GPE. GPE means geographical political. I think that's geographical political entity, meaning a place. That stands for place. So anything that represents place will be saved as GPE, meaning geographical political entity. Yeah. So that stands for place, Nigeria. You can say all of other ones. It didn't give us entity for all of the words there. So stays, he only give you the tag for that. That's why you need to first do the tag. Look at ASO Rock is giving us organization for that, meaning you recognize that ASO Rock is an organization. That's the way you recognize that. So if you want to, so named entity recognition is actually a live or a function or is a task that is done if you want to understand the kind of what you have in your text, the places, the people, the location you have in a particular text. But remember, you must first perform part of speech tagging. And is that part of the result of that is what you pass to the named entity recognition function to do that. So before I move to the last step, before I move to the last step, any question on named entity recognition?
None, sir.
All right. So far we've talked
Hello,
on.
sir.
Yes,
Hello.
sir. Yeah, I'm with you.
Yeah. Okay. Yeah. Oh, under this named entity recognition, is it pre-installed for it to be able to identify, like we have ASO Rock as an organization, GPE as Nigeria as GPE and all that?
Yeah.
Is it pre-installed or is it in the library? How does that happen?
Okay. Yeah, this natural language toolkit is a library that has been built for that. So inside this NLTK, remember NLTK is what we are using all through. It is also from there we get the word tokenize to tokenize and store. So this function named NE_chunk, which is in the NLTK, is what it has been built to recognize the entities in a particular text that you have already tagged. So it's pre-installed or is built in already. You get. So once you just get your text, you tokenize it, you perform part of speech tagging. If you throw it to this function, NE_chunk, named entity chunk, it will give you the entities there automatically.
Okay. Thank you.
All right, so okay. So that is that about that. So far we've talked on how to visualize our text using word cloud. We also discussed the importance of that, as one of the first things to visualize our text, because visualization is mostly the first thing I will advise any but there are any data analysts or data scientists to quickly to have a foresight of what your data, be it text or any other thing, is talking about. So that's what we've done. We've done the part of speech tagging, meaning we're trying to categorize each token or each word into its individual part of speech to be aware of the part of speech that we have, just to have an insight. What we are doing here is to derive insight from the text data. Then the next thing we did was the named entity recognition, which will help us to know the kind of the people, the places, the location discussed in the text. And finally, we've cleaned the text, we've removed stop words, we've removed punctuations, we've removed numbers and all of that. We've tokenized it and all of those things. So the final thing we want to do is, so we're assuming that our text is now clean, is in a ready state. So when you have done that, the final thing, suppose your goal is to perform a machine learning process on it. You want to build a machine learning model after you have already cleaned your text. Now, because machine learning algorithms, most of it, if not all, do not work with text. They work with numbers. They work with numeric data. So after you have cleaned your data, which is all we've been doing since yesterday up to today, you've tokenized, you move stop, or you visualize to derive insight. Now you want to perform, you want to do some machine learning process on it. You have to turn your text to numbers. And that is what we call word vectorization. In natural language processing, vectorization means converting your text to numbers, converting it to a numeric form that a machine learning algorithm can work with, can use to build your model. That's what we call vectorization in natural language processing. Other field may mean something, but when if you are talking about natural language processing, or you are talking to someone in this field, when you mention vectorization, even without saying word vectorization, when you say vectorization of your text, what it means is converting your text from text to numeric form, numbers that a machine learning algorithm can use to build a model. And that's the final thing we want to do today. So to do that, we'll go back to the scikit-learn library that we used during the first training. There is a function in scikit-learn called feature extraction.text. Feature extraction.text. So that's the function that is a function in scikit-learn that where we can get our vectorizer. So from scikit-learn.text, import, there are two different ones. So I will show you that and I'll tell you the difference. Import, let me press tab. See, one is, we have one here called the count vectorizer. And we have another one called the TF-IDF vectorizer. I will use the two and I will tell you the difference. So let me put comma, since both are there, so we can take the TF-IDF too. Now let me quickly talk about these two and tell you the difference between them. Count vectorizer, this is a method that we use to turn our text to numbers. However, this is what it's doing. What this count vectorizer is doing is that it's counting the words, the individual words in your text, and it's giving you the frequency, the number of times each word occurs in that text. That's all it's doing. Because knowing the number of times a particular word occurs in a text, sometimes it can give us an idea of the kind of discussions going on in that text. Because if a particular word like president Nigeria is occurring more in a text, then you might know that maybe that text is all about president of Nigeria. He's circling around him, things like that. That's what count vectorizer is doing. However, in most applications in the real world, it's not too, I don't want to use the word too good, it's not too efficient. Let me use that word. It's not too efficient because there are some words in natural language processing community. We believe that words that occurs many times may not really convey much meaning in that text. So that is where TF-IDF comes in. Now, TF-IDF is called term. TF-IDF means term frequency inverse document frequency, meaning the first two, term frequency, is also doing what count vectorizer is doing, counting the number of times individual words in that text occurs. But the IDF, the inverse document frequency, is now kind of a penalization, like kind of penalizing them, that it is assigning weight to those words, meaning that any words that occur more frequently, we carry less weight. And words that occur rarely, words that occur few times in that day, we carry much weight. This is the intuition behind that, is that the NLP community believes that the words that occur rarely in a text, we should actually be carrying much weight. We convey much more meaning compared to words that occur most times, well, frequently. So that's what this TF-IDF vectorizer is doing. And it has been proven to actually give better results compared to the count vectorizer. So I'm going to do the two. In this one, in this kind of text, it may not really make more sense because we are only dealing with a line, a text that is just a line. But I'll just do the two so that for you to see the implementation of that. So the first thing, instantiate the vectorizer. So let me resave this as count vect. And then the second one, let me use the TF-IDF vect. And so let's instantiate that. Okay. So that's what these two lines are doing, instantiating the two vectorizers. And the next line, I want to convert the text now, the tokens that you have already gotten from the text, to convert it to numbers. That's what this is doing. So call on the count vect that we instantiate, count vect. Call on the fit underscore transform. This fit underscore transform is what is turning the tokens to words, to numbers, to numbers, giving us the frequency of each word. That's what this fit transform is doing. When you have done that, what we have in these features are sparse array. When I mean sparse array, I mean an array of numbers that is mostly zeros. Only few ones. The one there is giving us the number of times the word occur. So to convert it to a data frame, I use the pandas. We looked at that last training. Panda. You can see how all of these things, all of this training fit into one another. You can see. So import pandas, call on the data frame. So these features, I convert it to an array because it's a sparse array. Convert it to an array. Then the columns, I will call on this my count vect that I already installed and call a function called get feature names. What this get feature names is doing is that it's going to turn each word there, as each word in our text, as a variable, as a feature. So get feature names, that's what it's doing. So if you run that, it's going to give you what is it the same text? I guess it's not using the same text. Okay, it's using this one, this particular one here, because that's what I save as tokens. That's what it's using. It's not using these because I saved this one as NE underscore token. So it's using this previous text, this sample text, which we tokenize and save as token. So you can see, the more the words you have, the more your column, your features will be, because it's going to turn each of the word to tokens. So that's why cleaning is good. So you can see it has 31 rows, 31 features. where each word stands for the token. So you can say Alabama occurs 1 times all of these. If we view, I only view the top 5. So if you view that, token occur 1 times in the second statement, in the second sentence, like that. So that's how to do that. If you want to use the TF vector, TF IDF, you can as well do that too. Just put TF IDF, fit. Let's use fit and put TF IDF vect, and then put fit transform. Then pass the tokens. So let's create a data frame too for that. I'll just copy this and modify that. So just put, let me put TF this, and I have this as the TF IDF fit, TF IDF fit, and then I think we save it as, so this one too will be TF IDF fit, TF IDF fit, and then we can check the head, TF this. What is the issue? Get feature names not found. TF IDF feed. What?
Yeah. No, I was.
Let me comment this. TF IDF feed. Oh, sorry. So this should be, what is wrong? TF-IDF feed features, yep. Convect. Oh, sorry, this should be TF-IDF vect, the vectorizer. Okay. All right, so this is it. Maybe I should view, let me view the last 5 and see, maybe we'll see. I wanted to, anyway, so this is the result of that. Because these are short text, you might not really see the difference, but you can see that this is decimal now, 0.01 point something. Is what is unlike the count vectorizer that is just whole number, 0, 1, like that. What the decimals are giving us, they're giving us the weights that the vectorizer has already assigned to each word. How does the weight comes about? The words that occur most often will be given less weight, meaning they do not carry much meaning to our text. While words that occur less frequently will be given higher weight, larger weights, meaning they occur, they make much more meaning compared to our text. So for the exercise, I want us to use, there are some text that comes in, text data that are also pre-built, pre-installed into the NLTK. And one of the texts is this text 1. So I will copy this and put it in the chat box. So from nltk.book, just import this one of these texts. If you want to install everything, just use star. But I only need text 1. So just import text 1, and then these are the steps, these are the things I want you to do on that text. So with that, I'm going to stop sharing. I'm going to stop recording so that you can do the exercise or any question. But before I stop recording, do you have any question on vectorizing your text?
Hello, sir. Sorry, I want to ask.
Okay.
Yeah, how are we going to get the recordings?
Yeah, it's on the YouTube. You can see that of yesterday is already on our YouTube channel.
Okay.
Yeah.
All right, no problem. I'll do that. Thank you.
All right, sir. So any other question before I stop recording? Okay, so let me just stop recording and